Hi class, this is course 2, lesson 47, powers of 10. Now before we can talk about powers of 10, we need to talk about rules or laws of exponents. And we have rules for when we multiply, for when we divide, and when we have powers. So, first off, remember that if you have a number to a power, this is the base and the exponent is that little number at the top. And that exponent just means take the base times itself that many times. Use it as a factor 3 times. Okay, so if we multiply like bases, so I need another 2 here, and I have another power. What this is saying is 2 times 2 times 2, that's here. Let's see, I'll switch colors for you. And then what if I use this one? So it's still times, and then I need 4 2's over here. So how many 2's do I have all together? 1, 2, 3, 4, 5, 6, 7. So I can write that in exponential form, 2 to the 7th. Well, there's a shortcut. If you multiply like bases, so if the bases are the same, and you are multiplying, then add the exponents. Okay, so 2 was the same, that's the base. I'm multiplying, so I keep the base, and then I add those exponents to get that 7. Okay, what happens when you divide? Again, we'll use powers of 2. If I have a 2 to the 5th power and I divide it by 2 squared, this works out the same way. I'm going to write 2 to the 5th. So I'm going to have 5 2's. And then I will have 2 2's in the denominator. And remember, if you have factors that are the same, you can divide them out and leave them with just 1's. Leaving you with how many 2's and how many, there are 3. So, if the bases are the same and you are, and so again, if the bases are the same and you are dividing, you subtract the exponents. So 2 is the base, so that stays, and 5 minus 2 is 3. Okay, one more example. That was multiplication and division, now powers. So if I have 2 to the 3rd power in parentheses, and I have that all to the 4th power. What I really have here is 2 to the 3rd power times 2 to the 3rd power times 2 to the 3rd power times 2 to the 3rd power, because I need to use that base, that item that is inside the parentheses, 4 times. Now we know up here we have like bases and we're multiplying, so we're just going to add all those exponents up. So that's going to be equal to 2 to the 3 plus 3 plus 3 plus 3 power, which is the same thing as 3, 6, 9, 12, 2 to the 12th. So, if you have a base, and what I call it, what it is, it's a power. Okay, so we have an exponent there to a power. Then you multiply the exponents. Okay, and I'll throw one more in there just for the heck of it. 2 to the 0 power is equal to 1. Any number to the 0 power equals 1. And the exception would be 0, but you don't need to know that yet. So we're just going to say any number to the 0 power is going to be 1. And that would go for variables as well. So if you get x to the 0 power, that is still 1. Okay, so you need to know all that so that we can do some work. So we can use powers of 10 to show place value and write numbers in expanded notation. So let's, before we write this in expanded notation, I'll just move this down here. We'll do that here in just a minute. Let's see. If I write, we'll start over here. 10 to the 0 power is going to equal 1. 10 to the first power is going to equal 10. 10 to the second power is going to equal 10 times 10, which is 100. 10 to the third power is 10 times 10 times 10, which is 1,000. 10 to the fourth is going to be 10,000. And hopefully you can see the pattern. And this only works with powers of 10. Okay, only with powers of 10 does this pattern work. That we get no zeros when it's a 0 exponent. We get 1 0 when it's an exponent of 1. You get 2 zeros when it's an exponent of 2, and so on and so on and so on. Okay, so 1 exponent, 2 zeros, 3 zeros, 4 zeros, and that will continue on. Okay, so we can use that information to help us with place value. So if we want to write this in expanded notation, we used to write, or one way that you can do it is 7 times 1,000, because the 7 is in the thousands place, plus the 3 times 100, because the 3 is in the hundreds place. Then we don't put the 0 down, plus 4 times 1. But when you're going to get asked to do this, write in expanded notation, but use powers of 10. And so what you really need to do, okay, so not this, we need to write this as 7 times, what power of 10 gives us 1,000? Well, we need 3 so that we get those 3 zeros, plus the 3 times 10 to what power will give us 100? 2 zeros, we need an exponent of 2, plus 4 times 10 to what power gives us 1? We need a 0. So this is the correct way when using powers of 10. Okay, this is still expanded notation, but it doesn't include the powers of 10, and that's what we're working on right now. Okay, now multiplying and dividing by powers of 10. When you multiply by powers of 10, if I take the number 22 and I multiply that by 10, I get 0, 2, 2. So if this problem were 22 times 10 to the first power, what I ended up doing was moving the decimal one place to the right. Okay, I'm making a bigger number, so I need to move the decimal to the right. And you can use that knowledge to help you when it's a power of 10 to do these problems really quickly. So when you're multiplying by a power of 10, you're going to move the decimal that number of places to the right. So 10 to the 6, I need to move 6 places, so I'm going to go 1, 2, 3, 4, and then I would have to go 5, 6, so I would have 2 zeros. Now don't do that. Okay, write your answer out, 3903,200, and put commas in where it's appropriate. You can double check to make sure you're right, because you could count backwards, starting from this decimal point and go 1, 2, 3, 4, 5, 6. Is that the number you started with, the decimal right here? Yeah. Okay, now dividing by powers of 10. If I were to take the number 4,000 and divide it by 100, I would get the number 40. Okay, so 4,000 divided by 10 to the second power gets me 100. You notice that this 2 and is exactly how many places I dropped off, or I moved the decimal in 2 places. I'm making a smaller number, so move the decimal 2 places, or that number of places to the left. Okay, not always 2. It's whatever the exponent says. So in this case, I would move, in 8.27 divided by 10 to the 5th, I'd move 5 places to the left. From the decimal, so not from the end of the number, from the decimal. So we'd go 1, 2, 3, 4, 5. That's where my decimal is going to be, and I fill in with those 0 placeholders. So I rewrite the number. I'm going to put a leading 0. 1, 2, 3, 4, 8, 2, 7. That's your answer. Okay, I have 3 problems for you to try on your own. I'll go ahead and press pause, and when you come back, I'll have the answers up for you. So this is 10 to the 3rd times itself 4 times, and that was the power to a power rule, so it'd be 10 to the 3rd times 10 to the 3rd times 10 to the 3rd times 10 to the 3rd, which is equal to 10 to the 3, 6, 9, 12th power, which you could have also gotten right here by multiplying 3 times 4. 17 and 97 hundredths times 10 to the 5th. I'm multiplying, so I'm going to move the decimal to the right 5 places. There are 2 here, so I need to move it 3 more, so 1797, and then the 3 more places. I'm going to put commas in where appropriate. I'm dividing, so I move the decimal 4 places to the left. 1, 2, 3, 4. Fill in with zeros, so I get the leading 0. Decimal point 2 zeros, 99563. Okay, you will need to refer to your books to get the place value chart. That will tell you all of the powers of 10 for powers of 10. Like it goes through what we did back here, only it'll list them like 10,000s, 100,000s, and that may be a page that you want to make sure that you know where it is in your book, because you'll be asked to write billions in exponents. And you can do that. You can write out an example and then count the zeros, or refer back to your book. Okay? With that, hopefully you have enough information that you can work powers of 10 pretty easily. With that, I'll see you in class.